Okay, so started recording. Uh, let's close this. Okay. So hi guys, long time no see. Today this video is all about me experimenting with building my own React. So a few days ago, I came across this blog post about creating your own React app, and it sounds fun to me to experiment. So thought of why not make a YouTube video with this, and it's been a long time since I've been like recording myself and building something. So let's not waste any more time, and let's get started. I may not understand all the parts of this blog post because it's quite complicated for my current level of expertise, but still I'll put up a good fight for the sake of this video. So let's hope it's fun. Okay. So it's the introduction about creating the React app. So not going to read it. I'll link this blog post in the comments. It's by Rodrigo Pombo. Like Rodrigo has been some awesome projects. Do check his projects out. And I will not read the introduction. Like it's quite obvious that what the introduction is about, like creating your own React app. So let's not go there. Starting, so the blog post is divided into 8 steps. The first is the create react function, which helps us create the elements. The render function, which helps us render the elements and so that we can view it on the screen. Concurrent mode, not entirely sure what concurrent mode does, but we'll get to know. Fibers, Fibers, I think, is a data structure in place for some functionalities of React internally. Let's figure that out. Render and commit phases. Don't know what this is. Reconciliation is a algorithm. According to what I know, reconciliation is the algorithm that React uses internally for rendering elements or something like that. Not too sure about some diffing algorithm kind of thing. We'll like look into the reconciliation part in the React docs. Function components, it's very simple, and the hooks, the latest features. So this is like quite a good deal of React. So step zero review. Okay. So first, so this is my first time doing this, so don't mind me reading out the blog post out loud. Uh, Please bear with me. I'll try to be as fun as I can be. So yeah, but first let's review some basic concepts about JSX, DOM, and how Element works. So we'll use React app, just 3 lines of code. The first line defines it. Okay, so it's an introduction about this React code that is written here. So okay, so I let me try to uh, start with here. So basically, what this is, it's like a JSX code that we use in React to uh, like uh, write. So it's like JavaScript plus HTML. It's like an embedded language. If you have heard about EJS, you may know what I'm talking about. So yeah, so JSX is basically a language that we use in React. Basically, syntax for the React, basically JavaScript plus HTML syntax that Babel compiles specifically for React, I guess. This is the container, the document.get. So you must be familiar with the get element by ID. We're getting the root ID. Uh, I can show you the root ID here, that going to the index. So this is the ID that we're tagging here. So our entire application will be embedded inside this div tag. So it's pretty clear now. Like I think most of the people know, because it's like the fundamental piece. These are the like fundamental pieces of React. React DOM render, so it's like simple render. Then it renders the element in the container. So like rendering all the pieces. Let me give it a read. We'll first show, okay, the first one defines the React element, the next one node from the DOM. So this is a node from the DOM that we have, the div element that we're targeting, and the last one renders the React element into the container. So this it's like embeds it into the container and then renders it. let's remove all the React specific code and replace it with vanilla JavaScript. So I guess this is the starting of the article. On the first line, we have the element defined with JSX. It's uh, okay. So yeah. So will how this blog post goes is like destructuring the JSX into like fundamental JavaScript pieces bit by bit. So this is not a valid JSX, as you all must know, because it's HTML also the H1 tag, and as we all know that it's if you have done any kind of programming language, this is not a valid JS code. So in order to replace it with vanilla JS, what do we need to do? We need to replace it with vanilla JS. So what JSX is, JSX is transformed to JS by build tools like Babel. The transformation is usually simple. Replace the code inside the tag with the call to create element, passing the tag name, props, and the children parameters. So what happens is like the JSX that we saw earlier. It's nothing but a simple JavaScript object that is fetched to the React create element method, so that it creates an entire component for us. So this is the syntax here. React.create element. So create element is an internal function that React uses. It takes the first argument as the type of the element tag that we want to create, and takes the props as an object, and the children property that is usually embedded in the element. So it's hello between the tags. So this is the children right now. So yeah, this children is hello. So right now I guess you're pretty much clear about what that JSX is. Moving on. So as I said, that's like uh, type basically of the element that we want to create, and props include title that, and the props is like basically an object. So title, you can, it's a normal key value pair. So basically title is foo. We can give any title here, and the children is hello. So we can we can include any children here for the purpose of this starting example. The children is hello. Besides some validation, that's all okay. So okay, yeah. So here is a quick refresher on React.create element. So React.create element creates an object from its argument, basically what I said. Besides some validations, that's all it does. So we can safely replace the function call with output. And this is what an element is: an object with two type and props. So prop is like the property of the object, a key value pair. It's just a syntactical, so no need to worry about it. The type is a string that specifies the type of the DOM node we want to create. Very evident. It's the tag name you pass to the document.create element. So you can it's like very much simple to the document.create element method that we have in the vanilla JavaScript, where like the type is like the tag name that you enter or give to the method, so that it creates that particular element we want to create. Okay. Props is another object. It does all the key and values from JSX attributes. It has a special property called children. Okay, children. Coming to children is the case. In this case, children is a string, but it usually is an array with more element. That's why elements are also trees. So basically, what this means is children, in this case it's a string, but usually children can be anything. So it's like a div h1 tag inside a div tag, and inside the h1 tag you can have a b tag for bold. So it's like an entire DOM tree in the form of children. So right now, for the starting example, it's hello, but it is usually an array with different kind of thing, uh, different kind of attributes that you can basically embed inside the your parent element, or the fundamental element that you're creating. So the other pieces of React code that we need to replace is the React. Okay, so the first piece is removed. So right now, what do we want to remove is like the uh, React. So what is React dot render. So what is the render thing that we need to replace? Okay, so render helps us view the elements on the screen. So render is where React changes the DOM. So render is the method by which React basically manipulates the DOM. So let's do update it ourselves. So changing this into the vanilla JS code we get for the render method that React provides us with is like if we had to basically mimic render, it's like uh, we first create a node, a normal node with the element type that we have, and then we pass the attributes given to that element type, uh, and for so then we create for the children we only have a string. So, okay, so basically this is what I told. So what is this text? Using text node instead of the inner text will allow us to treat all elements in the same way. So you must be wondering why we are not using dot inner text to embed the children. So there's a very particular reason for that. Using text node will allow us to treat all the elements in the same way later. So it's more of a generic way of treating all the elements in a similar way. Now also we set node value like we did it with the h1 title. It's almost as if the string had props. So yeah, so basically all the children are being embedded as node values. So like uh, the hello, and if it's an array, so it's one by one being embedded. So the node value is hello for right now. So finally we append the text node to the h1 and then the h1 to the container. So that's a clear embed here that you can visualize. So basically container a node, and the inside the node the container, and inside the container the text value that we have, basically hello. So it could have been any other thing, a b tag, a bold tag, or a italics tag, or a span tag, or anything could be there. So yeah, and now we have the same app as before but without using React. So yeah, we have been successful in creating that entire React code into a JS code. So yeah, finally we have text node. Okay, okay, okay. So what what is that create element function that React gives us? Basically, let's start again with another app. This time we'll replace the React code with our own version of React. So what we did initially was like converted the React code into a vanilla JavaScript code, but we were using some methods which were inbuilt to React. Right now, what Rodrigo aims to do is like uh, convert the entire inner functionalities into native uh, native functionalities built by us. So we'll start by mimicking the create element function. So let's transform the JSX into JS so that we can see the create element calls. Okay, so this is the create element thing. So there's a div, the element tag type, and props, the ID with the ID attribute as foo, and then another React create element called a null bar. So basically, uh, instead of so this as I mentioned, the children can be anything. So these two are the children element, which are in turn different elements. So uh, another create element. So the only thing that our function needs to create is the object. So yeah, you can visualize it as like this. So type and the props is an object with children as a attribute, children as a key, and the rest of the attributes. So we have used the spread operator for the props and the rest of the parameter syntax for the children. The way children props will always be an array. So yeah, children will always be an array because children can contain more than one attribute or more than one nodes to be embedded. Create element div. Okay, so this basically what div null a returns is like the type is div and the children is a. So you can visualize it as an anchor tag embedded inside of a div tag, and div null ab returns basically anchor tag inside of div tag, and like the b tag inside of the anchor tag. So children array could also contain primitive values like strings or numbers. So we'll wrap everything that isn't an object inside its own element and create a special type of text element. Okay, so the children can be any primitive value like numbers, booleans, or anything. So basically, now we'll make a different text element for that type. React doesn't wrap primitive values to create empty arrays when there aren't children, but we do it because it will simplify our code and our library we prefer. simple code than performing. Okay, so what Rodrigo aims to achieve with this blog is like the like he's preferring more of a simple code rather than a performant code, because for the like it's a very beginner friendly blog, so like not going into many details here. So creating another entirely new type for the different elements, the primitive elements that can be children number or something like that. So because it's not text or object or like any other primitive data type always. Okay, we're still using the act.create element in order to replace it. Let's give our library a name. We need to name that. Okay, so giving the right now we are using the react.create element, but we need to use our internal method for this. So for the sake of this blog, let's give it a name. So okay, so didact is the name that Rodrigo has given it. But we still want to use JSX here. How do we tell Babel to didact.create? Okay, so the main dilemma right now that we are facing is like how to tell the JSX, which is a compiler, to tell the application to not use the react.create element method, but instead our own create element method or function that we have defined up that we have defined here. Okay, so coming back to that, yeah, so if you have a component like this one, when Babel transpiles the JSX, it will use the function we define. Okay, so this if we comment out this line, basically what I don't understand Babel completely, but mentioning it here directs Babel to somehow use our create element function instead of the React create element function, which React uses internally, the render function. Now time to change the render function, because as we're building our React application, so we need to write everything from the scratch. So why not render function also? So for now we only care about adding stuff to the DOM, but we'll only handle update. Okay, so right now it's like the adding and updating, but the deletion, adding elements to the DOM, but later on with what this blog post aims to achieve is like the deletion and the updation of the elements as well. So we start by creating the DOM node using the element type and then append the new node to the container. Okay, so the logic is quite simple here. First, you create the DOM node by with the element type that is given, and then embed the container inside the DOM. So DOM node. So we could recursively do that for each child. So basically, how this flow is like you create a parent node and then you embed the container inside the node and create the elements inside the container. So it's like a hierarchies of elements embedded inside one another basically. We also need to handle the text elements. If the element type is text element, we create a text node instead of a regular node. Okay, so for the text element we need to create a different element type, because if the element type is text element, then we have to create a text node instead of the normal DOM node that we have been creating. So this is a simple ternary check for the element type, whether it's text element or not. The last thing we need to do here is to assign the element props to the node. Okay, so for the render, we are almost done with the render thing, but one more thing that we need is like uh, the props or the attributes that we can pass into a React application. So for that we need to uh, basically store all the property types to our DOM basically. So how we are achieving this is like we are abstracting out the key values and turning the key values into an array. So basically all the attributes like title or whatever value you pass to the HTML element, suppose say uh, is false or is any either boolean. Basically you make an array of those key values and then you filter the property, and then after filtering for the if it's a property basically, you like embed into the DOM name the name of that key. So this was a fairly simple application. So let and Rodrigo has given a code sandbox for it. So okay, let's try it out. Let me check if the screen is okay. Yeah, the screen is good. Yeah, so as you can see here, this is the create element which we internally created, uh, uh, taking children and taking props. This is the create text element if it's not a normal element, and if it's a text element. uh, Function render, so this is the complicated render function that we have built to mimic the react render function, which is nothing but checking for the element type and then creating a basically DOM node and copying all the prop attributes to it. Yeah, and this is the Babel direction for compiling it for using our internal methods. So that's that const, and this is normal React code that you may have seen. So let me play around with a little bit. Let's see if it works or not. Okay, yeah, it's working. It's working completely fine. Uh, let's what are the changes that we can? Okay, so I don't guess I don't think we can like uh, do much changes here because to include external files, I think I'll have to play around with it a little bit more, and with the current level of expertise that I have, I don't think I'll be able to do that. So it's working fine, I guess. Okay, let's so step three. Okay, step that's okay. So now coming to the step three, concurrent mode. So basically, what is concurrent mode? But before we start adding more code, we need. So right now the code will start getting difficult, I guess, and I'll try my best to understand it. But let's see how it goes. There's a problem with this recursive call. Once we start rendering, we won't stop until we have rendered the complete. Okay. Okay, so what the problem statement is, if I'm understanding it correctly. So right now, as the state of our code is, it embeds every element that we create inside the DOM node, but this is not the outcome that we want. So because creating elements inside of element will will cause us problem if we have a bigger bigger list of elements or bigger DOM tree. So it may cause trouble for the browser. So this is where I guess the concurrent mode steps in. So we are going to break the work into smaller units, and after we finish each unit, we'll let the browser interrupt the rendering if there's anything else that need to be done. Okay, so basically what concurrent mode is doing is like the rendering is being executed in smaller chunks, so that after each smaller chunk executes, the browser can interrupt if there's anything important that needs to be done, so the user experience is basically good. I don't understand all the technicalities of it, but the basic flow, the basic logical explanation here is very much clear to me. So because if there are too many elements, the R element will keep on embedding, and it may cause some problems for the browser, because if there is any element or an input or a input event triggered or any other thing that may require a visual appearance on the screen, it may be a problem, or it may be hindered due to the embedding of the elements. So this is how concurrent mode helps us uh, tackle that problem statement. So okay, so we use request id callback to make the loop. You can think of request id callback as set timeout. Okay, instead of first time run, the browser will run the callback when the main thread is idle. Okay, so as we all know, the set timeout, that is an inbuilt method that JavaScript provides us to uh, perform certain tasks at certain intervals. So request, we can visualize request ID callback function to be to be a similar function to that. where like it will direct the browser to run callback when thread is idle. So React doesn't use request ID idle callback anymore now, but for the sake of this blog, I guess Rodrigo uses the request ID callback to like make it simple. So request idle callback also gives the deadline parameter. We can use it to check how much time we have until the browser needs to take control again. Okay, so it comes with a deadline basically of to check which checks against the time until which the browser needs to basically regain the control of the application, because embedding if it goes on for too long, it may create some problem. So this is the logic that is here. So while next unit of work, so basically we'll be assigning it some unit of work, and while that unit of work is true, that next unit of work is like it is being passed on to that perform unit of work function. So that is the logic that we're being to, and when that function is performed, it becomes automatically false and this loop stops. So next unit of work, perform unit of work, and where is the perform unit of work function? So this is the perform unit of work function, still not defined. Uh, to start using the loop, we'll need to set the first unit of work and then write the perform. Okay, so that is clear function and not performance. Okay, cool. Okay, coming to fibers. What are fibers? To organize the unit of work, we'll need a data structure, a fiber tree. Basically, fiber is a data structure, fiber tree. So why that? Good question here would be to like think that why do we need a data structure here? What's the importance of data structure in building such a things? If you're like from Indian college, and you must absolutely hate data structures the way it is being teach, but this is a good application of where data structures can be useful. So we'll have one fiber for each element, and each fiber will be a unit of work. Okay, so basically what is like this root, div, and h1. So these are individual fiber elements, and each fiber element will require a certain set of work that needs to be done. Let me show you with an example. So okay, so this is the hierarchy that is here. So each one can be visualized as a fiber in the fiber tree. Basically, in the render, we'll create the root fiber. Okay, so in the render the root fiber is given, and the root fiber is firstly created. And so how fiber tree is right now architectured is like the every parent has a linkage to the to its immediate child, and every child has the linkage to the sibling elements. And okay, they will, okay, three things for each. Okay, so what perform unit of work function does? So perform unit of work function basically does three things: add elements to the DOM, very obvious; create the fibers of the element children; select the next unit of work. Okay, so basically it adds the current element, the element to the DOM for which the work has been done, and creates the fiber element for that fiber for the elements children, so that it can assign the children to the next unit of work, and the process can go on. One of the goals of this data structure is to make easy to find the next unit of work. That's why each fiber has a linkage to the first, and okay, as I said, it's like the goal of this data structure is to make it somewhat easier for the perform unit of work function to find like the next find or basically choose the next element on which the work has to be done. When we finish performing work on a fiber, it has a child, that fiber will be next unit of work. Okay, so like this is the previous part, that it's like when work is done, it goes to the next child element, and then when the work on the child element is done, is it goes to the next child element, and carries on in such a way. Okay, and fiber doesn't have a child or a sibling. We can go to the uncle, the sibling of the parent. Okay, so that's acceptable logic, I guess. If what if the fiber doesn't have a children or any sibling? So basically, it goes to its uncle, that is the sibling of the parent. So that's the data structure part. Don't want to go to too much depth about the data structure part, but you get the basic ideology what this data structure is being used for here. Uh, in the render, okay. So how is this logically connected? So like putting like we know what the data structure is doing. The difficulty with data structure is not understanding what the data structure does. It's integrating them into the code and visualizing how the data structures is useful in the code. So let us see that how Rodrigo plans to implement that. So first let's remove, okay. So removing the code from the render function, we keep okay. So some code is removed from the render function. Oh, okay. So what is done is like this create DOM. So what Rodrigo has done is like just created a separate create DOM function by removing some render by removing separating out the render function. Basically we keep the part create DOM in nodes in its own function. We are going to use it later. So that create DOM, so what Rodrigo has done is like separated out the render function and made create DOM as a separate function that can be used later on. In the render function we set the next unit of work to the root of the fiber tree. So basically the next unit of work is set as the root of the fiber tree so that it can continue that perform unit function, and it can continue traversing, and it can continue assigning the child or the sibling elements to the basically next unit of work. Then when the browser is ready, it will call our work loop. Yeah, same. So the work loop that we saw earlier, the while loop, I guess. Yeah, this while loop it will call, and it will keep running until it's true. Where we first we create a new node and append it to the DOM. This is the process that it has been from the starting. We keep track of the DOM node in the fiber.dom property. Okay, so that's something new. So the so the fiber has a DOM method or a DOM property that we can access to keep track of the DOM node. Then for each child we create a new fiber. If index.0, basically if the index is 0, then fiber.child is new fiber, or if it's not 0, then it's like embedded inside the parent, which is very much obvious. Simple ternary, simple conditional check basically to uh, introduce the child as a new DOM node or as a child DOM node, and we add it to fiber tree setting it. Okay, so same thing. Finally, we search for the next unit of work. We first try with the child, then with the sibling, and then with the uncle, and so on. The hierarchy is uh, same. Coming to the fifth part, that is render and commit phases. So what are render and commit phases? I don't know much about render and commit phases. Let's try to figure out what render and commit are doing here. So we have another problem here. We are adding a new node to the DOM each time we work on element. And remember, the browser could interrupt work before we finish rendering the whole tree. In that case, will the user see an incomplete? Okay. Oh, so that is a good concern, to be honest. So what's the concern here? So initially we told that if we allow the application to keep rendering elements, it may cause some problem for the browser. So we are giving browser some certain set of function permissions basically to interrupt the rendering cycle. But what happens when the browser interrupts the rendering? Will the user see incomplete UI? And to go back to the uh, browser having permission to disturb the rendering cycle, it was here the concurrent mode. That is where the concurrent mode comes in. So it's the concurrent mode. Through the concurrent mode we like allowing request id callback. So so through this we are allowing the browser to interrupt basically when the cycle is idle, or like when to execute the logic into smaller chunks of code. Coming back to rendered commit phases, yeah. So what can be the solution to such a problem? So we need to remove that part that mutates the DOM from here. Instead, we'll keep track of the root of the fiber tree. We call it work in progress root. Okay. So basically, what it's very simple, the logic to understand. So basically what it does is like the node on which which is being worked on, it is being removed. So it's kept idle, so that it can work idly until it finishes its task or its creation. So let me simplify it a little more. So we need to remove the part that mutates the DOM for it from here. So that mutate is like changes the DOM from there. We'll keep a track of the root of the fiber tree, call this work in progress root, and once we finish the work, we know because this isn't the next unit of work, we commit the whole fiber tree to the DOM. So what we separate out the DOM when the work is finished, and we commit the whole the fiber tree to the DOM. So that in that way the user doesn't see an incomplete UI. So you can like visualize it as working on GitHub if you have worked on GitHub. So basically you can work on multiple branches. So if your teammate is working on one branch and you are working with some different features, so you can create another branch so that both of you doesn't so that both of you basically don't interrupt each other's work and everything is like harmonious. Reconciliation. So I particularly wanted to understand what reconciliation means. So let's search React docs for a little before going to Rodrigo's explanation. So React provides a declarative API so that you don't have to worry about what changes on every update. This makes writing application. Okay, okay. So basically, reconciliation is the way of React. Is React's way for checking changes or tracking changes that is happening in the DOM, and it works on a very particular algorithm called the diffing algorithm. Not going into the details of diffing algorithm, but to be like the basic gist of what diffing algorithm is like. When diffing two trees, React first compares the two root, and so basically what React is like. React behaves. What diffing algorithm, in my opinion, is like React behaves in a marginal kind of way. So only tracks the changes. So if there's a particular change, React knows that change and it renders the DOM in such a way so that only the change is updated and the rest of the elements remains the same. So far, okay. That's what we are going to do now. We need to compare the element we receive, and okay, that is the update and the tracking the changes part. So we need to save the reference that last fiber tree we committed to the DOM. After we finish the commit, we call it the current root. Yeah, that's a normal I guess syntax or terminology. We don't that even if we do not understand, or we don't have to care about this, I guess, much. So now that what is happening is we add the alternate property to every fiber. The property is linked to the old fiber, the fiber that we committed to the DOM in the previous commit phase. Okay, so what is happening is like we are saving the reference to the last fiber tree that we committed after we finish the commit. We'll call it the current node, and we are also adding the alternate property to every fiber. The property is a link to the old fiber, the fiber we committed to the term in the previous committed. So that's pretty simple, because like the fiber that we committed to the DOM, we call it the current root, and we have a property linking it with all the other fiber nodes. Let's extract the code of performing. Okay, so now what is we are doing is like perform unit of work code that basically divides the code into smaller chunks with the is being extracted out to a new reconcile children function. So we have created a new function called reconcile children. So what let's see what this function is doing basically. um, Here we will reconcile the old fibers with the new element. Okay, we compare. Basically, reconcile means comparing. So I guess reconciling means comparing. So basically, it's like comparing the new and the old elements and tracking changes that are being done. We iterate the same time over the children. Okay, and the array elements want to reconcile. So we have given it an alternate property. Remember that links it with basically every other child. So this is helping us in tracking the changes, I guess. Um, if we ignore all the boilerplate needed to iterate about the array and the linked list at the same time, we are left with the matters most inside this. So basically, it's like comparing the changes we need to. So what's important with the element is the thing wanted to render the DOM and the list. We need to compare them to see if there's any change we need to apply to the DOM. Okay, yeah, that's obvious with the way how React works. to compare them. So if the old fiber and the new element have the same type, we can keep the DOM node and just update the new props. Very, I guess, simple. If the type is same, we can just update the property values. If the type is different, there is new element, it means that we need to create a new DOM node. And if there's different, if the types are different and there's an old fiber, we need to remove that old node and replace that node with an entirely another node. So here React also uses keys. So this is a good part, like to understand why keys are helpful. The keys helps us track uh, the changes, particularly with the React reconciliation algorithm. Here React also uses keys that makes a better reconciliation. Okay, we also need we have added a new property called effect tag. We'll use the property created during the commit phase. Let's see what it is. Then for the case where the element needs the new DOM node, we tag the new fiber with the placement effect tag. Okay, so what is this effect tag or the placement effect tag? And for the case we need to delete the node, we don't have the new fiber. We just have to effect it to the old fiber. Okay, so basically what is happening is when the old fiber and the emitter. So basically what we are doing is we are adding a new property called effect tag basically. So when do we use this property? To be very specific. So uh, whenever a new DOM node is being created, we tag the new fiber with the placement effect tag, and uh, whenever there's a case when we need to completely replace an entire fiber node, in case there are different properties or different types of elements, so we instead of we don't have a new fiber, so basically instead of to rectify to basically recognize the node, I guess we add the effect tag, if I'm not uh, wrong. And for the case where we need to delete the node, we don't have a new fiber, so we add the effect tab to the old fiber. Okay, so when basically if we do not have a new fiber, we just add the effect tag. But when we commit the fiber tree to the DOM, we do it from the work in progress route, which doesn't have old fibers. Makes sense, because so that it doesn't break our UI. So we need the array to keep track of the nodes we want to remove. And then when we're committing the changes to the DOM, we also use this fiber from the array. Now let's change commit function. Okay, so commit function that adds basically the effect tag. If a fiber has a placement effect tag, we do the same as before. We append the DOM node to the node from the parent fiber. If it's a deletion, we do the opposite, remove it from the child. And if it's update, we need to update the existing DOM node with the props as change. We'll do. Okay, so this is how I guess some React reconciliation works immediately internally. Basically, it gives tags to the changes that are tags on the basis of these changes. I guess if the old fiber and the new, and these three types of changes, and on the basis of those tags, React checks whether a deletion, update, or whatever the functionality that needs to be executed. Special kind of, okay, it's the same. Coming to the seventh, seventh part, it's function component. Next thing we need to add is support for function components. So I'm like intrigued how do you add support for the function components. First, let's change the example. We'll use the simple. Okay, so let's using the simple h1 tag here. Basically the John Doe of element tags, I guess. Note that if we transform the JSX to the JS, it will be okay. So we have seen what the transformation of JSX to JS looks like. Function components are different in two ways. The fiber from a function component doesn't have a DOM node. That is new. The fiber from a function component doesn't have a DOM node, and the children come from running the function instead of getting them. Okay, so in the function component, you have to run the function to get the children instead of getting the children directly embedded. We check if the fiber type is a function, and depending on that we differ. Okay, so the type of the fiber is being checked. If it's function, then the executions are different, and if it's not a function, the execution is as we have discussed in this blog post. In update host component, we do the same as before, and in update function component, we run the function to get the children. So basically running the function to get the children so that we can embed it into our fiber tree. For example, here the fiber type is the app function, and when we run it, it returns h1 element. Then once we have the children, the reconciliation works in the same way. We don't need to change anything there. What we need to change is the commit work function. Now that we have fibers without DOM nodes, that is the functional components. We need to change two things. First, to find the parent DOM node, that we need to go up the fiber tree until we find the fiber with the DOM node. And when we remove a node, we also need to keep going until we find the children DOM node. So not entirely sure what this is, but let's read it again to understand it. So now that so as we know that the fiber from a function component doesn't have a DOM node. So uh, basically what is happening is like, uh, if what we need to change is, now that the fiber, as the fiber from the function component doesn't have the DOM node, so uh, we have to do certain set of tasks. So it's like finding parent of the DOM node. We'll need to go up the fiber tree until we find the DOM node, or for the children we need to go down until we find a child with the DOM node. Cool, cool. Coming to the last part, hooks. So last step now. Okay, so let's change our example to classic counter component. That is the most famous one. Now that we are using direct.useState to get update and the counter value, here is where we call the counter function from the example, and inside the function we call the useState. Okay, so this is our useState function, the useState function which actually React also uses internally, and this is our update component that is like working with the in parallel with the reconciliation algorithm. So we need to initialize some global variables basically calling the function component, so we can use them inside the useState function. First, we need to work in progress fiber. We also add a hooks array to the fiber support, calling useState several times in the same component, and we keep track of the current hook index. So not entirely sure what it means, but let's continue reading. I think it will get clear. When the function component calls the useState, we check if the old hook, we check if we have an old hook, we check if the alternate of the fiber. Okay, using the hook index. We have an old hook, we copy from the state from the old hook to the new hook. If we don't have any child, this check. Okay, so basically how it's checking, you remember at the starting we gave an alternate property to the set of fiber nodes, so that it has a linkage with the previous node, which also by the way helps in making the connection while comparing. So what the hook logic does is like checking basically uh, if checking for comparison. So basically if we have an old hook, we copy the state uh, from the old hook to the new hook. If we don't, we like reinitialize an entirely new useState hook. Then we add the new hook to the fiber increment and the hook index by 1. So that's it's the use state function is a bit complicated, having some difficulty in understanding it. UseState should also return a function to update the state. So we defined a set state function that also receives an action. Okay, for the counter example, so that's how we set state, and then we do something similar that we did with the render function, set a new work in progress route while it is setting a state basically, but we haven't run the action yet. We do it next time we are rendering the component. We get all the actions from old hook queue and then apply them one by one to the new hook state, so we return the states updated, and that's all we have built. Okay, so as you know, that React use state is asynchronous, and I think I just figured out why the React use state is asynchronous. So basically what happens is like use state should return a function to update the state. That is very common because it's the use case for use state. So we define a set state function that receives an action for the counter. Example, this action is the function that increments the state by 1. Action, you can visualize actions as just another function that will be executed as callbacks, I guess, to update the state value. We push that action to a queue we added to the hook. So we push that action, or we push that function to a queue, and then we do something similar to what we did in the render function. Okay, so we did this in the render function also, to set a new work in, so we are setting up entirely new work in progress route as the next unit of work, so the work loop can start new render phase. So basically whenever we're passing that function that needs to be executed as a callback, we are setting an entirely new work in progress route that will start a new render phase. Basically that will trigger a new render. So but we haven't run this action yet. What we do it next time we are rendering the component, so it doesn't happen here. So this creating the work in progress route and running the action is not simultaneously. That is why the state is asynchronous. We run the work in progress loop when the component is rendering the next time. So basically if we click on the counter one more time, it will run and then it will like render and the value will be updated. So that was it. uh, I hope I tried to make myself clear. I also gained a lot I like gained a lot of clarity about understanding how React works internally. Even though the technicalities were difficult, it was, I think, a good experiment to figure out a blog like this. I think I'll be doing more of such experiments in the future. Uh, 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 so I guess I don't have much to say, but yeah, uh, got a basic gist of what React is. Kudos to Rodrigo for writing such a blog and making such projects. Hope to accomplish uh, a similar project one day. Right now, it seems very out of bound for me to implement such a thing, but yeah, glad that I tried to scratch uh, some somewhat how React works. This is, I guess, so going back to the initial code base that Rodrigo has given us. Yeah, I guess I'll try to play around with this, see if I can make anything out of it. Uh, these are the core aspects of React, I would say, and we have gained a very good understanding of how React is made internally and how React works internally, especially the reconciliation, the concurrent mode, and the data structure. The how React decide which elements to render and which elements to not render. I guess those things are pretty much clear. Enjoyed reading it, so that's it, I guess, for an experiment to uh, read a blog post online, I guess. So that's it, guys. Me projecting my understanding of how to create a React application on our own. See ya.